Okay, in this video, I want to tell you about a feature of C++ that builds off some of our prior discussion of encapsulation and operator overloading. And what we're going to look at here is the function call operator and an idea of a special kind of object called a functor. So a function call operator is one of the operators we can overload in the C++ language. It looks kind of weird because it's specified by parentheses. So on some new class, I'm going to call this class function, I can provide a new operator, a new function call operator. And we write it out this way. Int is the return value. And then we have the operator keyword and then parentheses saying that we're overloading the parentheses operators. And then it's going to take an integer as an argument. And then all it's going to do is return that integer. Okay, and then down here in my program, I create an object of type function, right, called f. And then I use this operator on f by just putting parentheses immediately after the object name, and then putting the argument I want to pass to the function, inside those parentheses. Okay, and this notation, it looks like a function call, but it's not. This is going to call the function call operator on object f with argument 5 and get and basically just give us 5 back. And so in this case, what this line of code is going to do, I pass 5 into object f, it's going to return 5, and then I'm going to print out the number 5. Pretty neat. Look at a little more detail at this, right? What this operator says is that I can use an object of type f as like a function call, and I can just put parentheses after the object name and then pass arguments in, and that's asking the compiler to use the function call operator on that object. I can have as many arguments as I want. They can be any type that I want, any class that I've created, and references or whatever else. So this list of arguments can be arbitrarily long. And then this function body can do whatever I ask it to do, right? And then this return type can also be anything I want it to be. So this function call operator can be customized to look like basically any kind of function call you want. Because this object is basically all it's doing is providing this operator, this function call operator, it basically is an object that works like a function. We're encapsulating a function as an object. And so this is called a functor. It's a special kind of object that works like a function, and it's called a functor. When we want to invoke it, like I showed you before, we just have to say the name of the object, not the name of the class. Note, the name of the class was function. So the name of the object is f. And then all I have to do is take f and put parentheses on the end of it, and then put the arguments in that I want to use to call it, just like a normal function call. Right? This looks like a function named f, but there's not a function named f. There's an object named f, and I'm calling the function call operator on that object. The compiler is going to figure out that this f here is not a function, that it doesn't need to find a function, that all it needs to do is look inside object f for the function call operator. So that's pretty neat. Okay, so why use a functor? Well, an object whose sole purpose is to provide a function. Sorry, let me start over. So the reason we might want to use a functor is when we would like to configure some functionality, and we would like to be able to pass that functionality in as an argument, maybe in a constructor or in a template, to control the behavior of another class. An example might be that, let's say you want to implement some sort function that would sort objects, from smallest to greatest or greatest to largest, but you don't want to hard code which way you sort them into the sort algorithm. So what you do is you pass in, using a functor, the exact sort of comparison you want, either a less than comparison or a greater than comparison. So functors give us that ability to alter how something works by passing in a function as an argument. And you'll see functors get used as a member of a class, as an argument to a function, or as a template specialization in order to alter the behavior of some other class. We're going to see some examples of how this works. as we go. So a function call operator allows us to encapsulate a function inside an object, and we can specify arbitrary number of arguments and an arbitrary return value. An object whose sole purpose is offering a function implementation is called a functor. And we can use functors to customize the behavior of other objects.